Do you know why your car or bike battery doesn't run out even after powering headlights, ignition, horn, dashboard, and more? It's because of a small but powerful device, the dynamo, or more commonly today, the alternator. In this video, you'll understand how a dynamo works, how it charges the battery, and why it's one of the most important components in any vehicle. Let's begin. A dynamo is a device that converts mechanical energy into electrical energy. In older vehicles, pure dynamos were used. In modern cars and bikes, the advanced version, the alternator, does the same function but more efficiently. So basically, engine rotation dynamo / alternator electricity battery charging. The working principle is based on Faraday's law of electromagnetic induction, which says whenever a conductor cuts magnetic field lines, electricity is produced. Inside a dynamo, a rotating magnet or rotating coil moves inside a magnetic field. This movement generates AC voltage. The AC is then converted to DC. That's the fundamental science. Let's open up a dynamo mentally and see what's inside. First, the rotor, connected to the engine pulley via belt, spins at high speed, creating a rotating magnetic field. Next, the stator. This is a stationary set of copper windings. Electricity is generated here. Then, the rectifier, also known as the diode assembly. It converts AC to DC, ensuring current flows only in one direction towards the battery. Fourth, the voltage regulator. This keeps output voltage stable, around 13.5 to 14.5 volts, protecting the battery from overcharging. Finally, the pulley and belt. These transfer engine rotation to the alternator. So the engine rotates, rotor spins, AC-produced rectifier converts battery charges safely. When you start your car or bike, the battery gives initial power. But once the engine is on, the alternator begins spinning. It generates AC, the rectifier converts it to DC, and the voltage regulator adjusts it to a safe charging voltage. The DC flows into the battery and charges it. This ensures your battery stays charged, powers electrical loads, and remains healthy over long use. At idle RPM, the alternator charges slowly. At higher RPM, charging is faster, but always regulated. Now, let's compare cars versus bikes. In cars, you'll find bigger alternators, typically ranging from 60 amps to 150 amps. These are capable of running AC, headlights, music system, sensors, ABS, ECU, and more. They also provide highly stable charging voltage. In bikes, you usually find a stator/rotor alternator, often a magneto type, with lower current output. It charges the battery and powers the headlamp and ignition. It also works even at low RPM using permanent magnets. What if the dynamo fails? If the dynamo or alternator stops working, your battery won't charge. Your headlights will dim, the horn becomes weak, and the vehicle may even stall. The dashboard will show a battery warning light. In bikes, kickstart may still work, but electricals become weak. Now, let's look at the symptoms of a bad dynamo. The battery warning light glowing is a key indicator. You might also notice dim lights at low RPM or a burning smell or noise from the belt. Another symptom is a weak battery even after recent charging or a multimeter reading less than 13 volts while the engine is running. A dynamo or alternator may look small, but it's the powerhouse of your vehicle's electrical system. Without it, your battery would drain in no time. If you found this explanation simple and helpful, do like, share, and subscribe. This is Simple GAN, turning complex engineering into simple knowledge. Thanks for watching. See you in the next video.